tell from my accent that I'm from across the road. Today we'll be looking at one of the products that we're going to be releasing very shortly to help build private cloud style scenarios on top of our virtualization stack. So what we're looking at today is the System Center Virtual Machine Manager Self-Service Portal version 2. I don't know if that's the longest product name in our portfolio, but it's going to be pretty close. I've been told it's a claim to fame, so I'll officially claim it. So this is what we're covering today. The Self-Service Portal 2, I'll just call it the SSP for short from this point, is currently in release candidate. That release candidate is public and can be downloaded. And they're aiming for RTM or to release to web actually, because it doesn't go and have disks pressed. We'll release to web. The aim is Q4 calendar year this year. So just to give you a little bit of background on me, again, I'm a consultant, so I actually spend my time on customer sites actually working with the technology, helping people get it to work and get it to do what it's supposed to do. So you're not going to get a fluffy marketing discussion about cloud. This is about the technology. It's about the nuts and bolts that we have to actually enable these scenarios and where it starts getting real. I was the Asia Pacific lead for the early adopter program for the self-service portal, so I've seen it from its very, very early cuts up to the release candidate, which I'll show you today. And also received a lot of the feedback from the early adopter customers about what they'd like to see in it and how it was shaping up. So what I'll do is I'll just start off with a little bit of background on cloud, where we see cloud services and the separation between public cloud and private cloud, where the product sets fit within those two cloud scenarios, just to give a little bit of context as to where the SSP fits and where we think it plays. I do want to say up front now, this is not the only way that you can achieve private cloud style scenarios. It is one of the ways that we are giving you to try and achieve those goals. But firstly, I think I should probably start off by defining cloud, because there's not much point saying this is what we give you to facilitate private cloud without some kind of definition around what private cloud actually is. Then I'll go into where the self-service portal actually fits within that model and the scenarios that it covers. And then we'll actually have a look at the SSP. Now this is an overview, so I don't go deep into the technical. This is a 200 session, so it's an overview session. There is some related content that you can go and have a look at after this if you want some more detail on some of the other components. But I'll cover the logical concept of how it fits together, some of the terminology that we use within the portal, the user roles, various physical components that make it up. I'll be giving you a demo of the configuration, so what it looks like from the administrator's point of view. I'll be explaining the concept of chargeback and how it applies within the portal, and then also I'll finish off with a demo of the onboarding and infrastructure approval process. So now, having said that, I wasn't going to, be all marketing and cloud and get all essentialism on you. I'm going to start off with some marketing slides. You can tell they're marketing slides because they look good. And they've got nice animations in them and stuff. You'll certainly see the difference when you start getting into my slides. So why clouds, and what is all this talk about cloud? For those of us who have been in the industry for, I guess, I've been in it for about 15 years, I suppose, there have been quite a few little things that come along that look like they're going to be the next big thing and a fundamental shift in the industry. I mean, for those of us who were around when Thin Client first started, that was going to take over the world, and then VDI was going to take over the world, and these things then have a way of sort of, I guess, settling down and finding their natural place in the ecosystem, and maybe don't end up being the big things a lot of people thought they were going to. Cloud, though, I can see from what I've been seeing overseas as well, I think we are headed for a fundamental shift in how services are deployed and how we manage infrastructures. And we're now at the very ground levels of that, and we're at the first stages of that. So why all the hype around cloud? Well, from a business perspective, you can certainly see its appeal, particularly when you start looking at public cloud. One important distinction to make between public cloud and private cloud straight off the bat is that first pillar there of managing costs, the shift from capital expenditure to operational expenditure. So with a public cloud, using, say, Exchange Online as an example, you don't have to buy your servers and rack them and feed and water them and put Exchange guys on staff and do all that kind of thing to manage your mail capacity. You simply purchase the mail capacity and then pay for what you use, which is the idea of public cloud. A lot of people use the analogy of it's like electricity. You flick your switch on, you get your light, you turn it off, and you pay for what you use. That's a shift from capital expenditure to operating expenditure, which obviously a lot of CFOs very much like the idea of. Not so with private cloud. Private cloud, it's yours, it's your kit, it's in your data center. You've still got to feed and water it, you've still got to manage it. So you still have that notion of the capital expenditure there that you need to facilitate what you want to do. And then the other three pillars really are based on the fact that virtualization is a key technology component to enabling cloud and enabling cloud scenarios. So it's about being able to rapidly provision capacity. And as I get into the SSP, you'll see rapidly provisioning machines or virtual machines from templates in far less time than what we used to do when it was all about physical servers. That's nothing new. That capability's been around for quite some number of years. So I won't get up here and say, oh, wow, you can do it in minutes, because that's not exactly an exciting thing. But when you look at the practical considerations that have to go in play when you actually do provision a machine, from start to finish, often the provision of the actual operating system from a VM template is only a very small component of it. There's stuff that has to be done before and stuff that has to be done after. That if you're trying to get to a truly agile state... Someone trying to signal me there? No? You're right? Okay. If you're trying to get to a truly agile state, there's end-to-end processes that have to be taken into consideration. But it's about greater resource agility, so being able to provision things to people quickly so they can focus more on what they do, which is the business component, so they're not having to be concerned with the nuts and bolts of IT. And of course the last slide there, lower carbon footprint, all that good stuff that comes with virtualization, so higher server density, less servers, less power, less cooling in your data center, blah, blah, blah. Again, nothing new there. That's been a known state of play for quite some time. So what defines a cloud? So if we're going to talk about it, let's define it. These are some of the key elements that we believe need to be present for something to be defined a cloud. Now, it has to be said that this isn't a hard and fast sort of rule that absolutely all of these have to be in place or it's not really a cloud. It's about these are the parts that we believe make cloud services of value and actually make them something real as opposed to just a marketing term. So self-service. You want to delegate the ability for people to provision their own service so they don't have to be engaging IT for that. So then that makes it service orientated. So you're producing a final product to someone at the end of the day that they can simply consume. It needs the ability to scale out, and that also comes to the last point about it being elastic. It needs to scale up and down on demand. Consumption-based charge, so people are paying for what they use. So in times of higher load, service scales out, they'll pay a greater amount, which hopefully they should be able to cover because they'll be getting more income if their service is being more widely used. And then during lower times, it scales back and then they're charged appropriately for that. And of course, then also failure resistant. Now, not all of these may apply to private cloud, depending on that really defines public cloud in the broader sense. But there are elements of this that we do want to bring to private cloud as well, because just because we're not getting the shift from CapEx to OpEx, we still have our own CapEx. That doesn't mean that we can't grab some of the other elements from cloud that are of great use to business in terms of the agility and the rapid provisioning and the chargeback model that then can't be applied internally within a business if that makes sense for that business to do so. So let's have a look at the spread between public and private cloud and some of the technology sets so we can put it into a little bit of context. So we really see it as three things: infrastructure as a service, platform as a service, and software as a service. And then broadly, the three are defined as IT as a service. There's a little bit of misconception out there, I think, that that the three are somehow you have to get to infrastructure as a service before you can provide platform as a service, and then your final utopia is software as a service. That's not necessarily true. These things are separate. There'll be cases where infrastructure as a service and only infrastructure as a service is appropriate, and then other times where software as a service is appropriate. So it really depends on who your end customer is and what they're needing to consume as to which one is appropriate. You may be providing one or both or all three. It doesn't really matter the combination and how that's done. So let's have a look at some of the technology sets that enable these cloud scenarios. So you've got the core of Windows Server and the System Center products providing your infrastructure. That's true for both private cloud and public cloud. Then platform as a service. So we're talking about internal software development here when we're talking about private cloud. You've got your old favourites of .NET, Visual Studio, SQL Server. Then when we move to public cloud, that starts getting into the newer technology sets. So you've got Windows Azure or Azure, depending on how you want to pronounce it, SQL Azure, and the Live Services platform. And then within private cloud, software as a service, SharePoint, Exchange, Dynamics, etc. So again, to address, I guess, a little bit of the cynicism that may be out in the marketplace around defining cloud and IT as a service. So a lot of us are looking at it saying, well, IT as a service, that's pretty much what we've all been doing for about the last 10 years. Give you an example. If you've got a SharePoint infrastructure, for example, within your business, IT maintains that SharePoint infrastructure. A business unit might come to IT and say, we need a collaborative capability, we need a team site. Okay, we'll provision you a team site, we've set it up, there you go, there's your team site, you've got your capability and that business unit is happy. That was provisioned on the existing infrastructure that the IT team had in place. So that sounds like infrastructure as a service to me, or even that's software as a service. So that providing that as a capability in concept really is nothing new. But when we're talking about cloud, we're talking some of the extra elements to that. So that would be instead of the business unit having to come to IT and ask for a team site, they just hit a portal and provision their own. So then when we're talking about software as a service in the public space, then you're talking about Exchange Online, SharePoint Online, BPOS. So what we're talking about today, though, is the Self-Service Portal version 2, which sits in infrastructure as a service within private cloud. I also want to mention the Dynamic Data Center Toolkit for hosters because there has been a little bit of confusion between the two. The Self-Service Portal has been renamed about 25,000 times since it first got started. One of its original names was the Dynamic Data Center Toolkit for the Enterprise. So if some of you have been following it, may be more familiar with it under that name. Dynamic Data Center Toolkit for hosters, which is on the right-hand side of the slide there, that's been available for a while. And the idea there is to give hosters or people who are provisioning public cloud capability with the ability to leverage the System Center suite and our virtualization platform to effectively create their own self-service portals that'll service their needs. So the Dynamic Data Center Toolkit for hosters is not something that you install. It's a set of documentation, a set of best practices and sample code that enable you to build out your own portal leveraging our virtualization stack and the System Center suite. So this will be the focus of the rest of the topic, and I won't mention anything more about the Dynamic Data Center Toolkit for hosters other just to put it in its context against the SSP. So the SSP is effectively the toolkit for hosters, except we've already written the portal. It's already there, we've given you the framework, so it's a matter of installing and then leveraging that. So what was the vision of the SSP? Before I mentioned that in terms of provisioning a truly dynamic service, the actual provision of the operating system from the virtual machine is only one component. There's usually always things that need to be done pre or need to be done post. The idea of the SSP, the concept, was to give you a framework, to give you an engine that enables you to automate that from end to end. But again, it's about cloud, it's about service orientation. So ultimately, I want my customer, my consumer, to request a VM I want a VM spat out the other end that is ready for them to consume. So that might mean, let's say you're provisioning a SQL server, for example, and the SQL guys complain, because SQL guys always complain, about I/O. They want more spindles, faster I/O, more spindles. I mean, they never shut up. So quite often they'll complain, I don't want the virtual disk. It's not fast enough for me. I want raw disk straight back to the SAN. So you may have to provision LUNs before you can create that virtual machine. Or alternatively, it might be a web front end, for example, that you want to participate in some kind of load balancer. So you may have to chuck it across the fence to the comms guys, who then put the IP configuration into their load balancer. And these are all things pre and post. And then it'll go to the infrastructure guys who have to go through their checklist, make sure that it's installed and properly configured within whatever management suite is looking after the box, or confirm that it's got antivirus on it, and all these sort of things that normally they go through their checklist and go, yep, everything's there, big tick, I can now support this server in a business as usual sense. It's now ready to be consumed by the customer. So the actual VM provision is only one component of that. There's always stuff pre and post that needs to be done. And that was the idea of the SSP, is to give you the engine, the framework, to automate that completely end to end. So I'll just get a quick show of hands. Has anyone familiar with System Center Virtual Machine Manager and the self-service portal that comes with SCVMM? One. Awesome. I was hoping for a bigger show of hands than that. The self-service portal that ships with System Center Virtual Machine Manager is a web interface to SCVMM that gives people the ability to create virtual machines. You do all the basics that you can do with them, you know, start, stop, load them into a library, load them from a library, all those types of things that you generally want to do with virtual machines. What the SSP version 2 does is it does that core function of interacting and creating virtual machines, but it then brings two additional components to the party. The first thing it brings is a onboarding business unit registration process, and this is about the self-provisioning. So business units can register to the system, and I'll go through that process in detail, so I won't explain it now. But they, once registered, they can then request and provision virtual machines from there. And the way that it's done is to try and maximise the agility of when they actually want to provision that virtual machine that happens as rapidly as possible. It also introduces the notion of chargeback, and I'll go into that into detail, where obviously you want people to pay for what they're consuming potentially, so it introduces a chargeback model so you can gauge relative resource consumption across business units. And the third thing it brings is a scripting extensibility engine, which allows you to automate end-to-end that whole provisioning process. And that includes also potential interaction with other hardware devices like SANs and load balancers and those types of things. So let's have a look at the logical concept, how the portal actually breaks down and how we treat things logically within the system. So we've got, the idea is we have a shared pool of network, storage and compute within our data center that we actually want to carve up and make available to different business units. So we have a business unit, in this case human resources, that have registered to the system. So they've had their registration approved, so they're now an active and known business unit to the system. They want a share of that infrastructure that we have in our data center. The first thing that a business unit does is requests a block of infrastructure. Now, business units can have as many infrastructures as they like. You can carve this up however you like, but we would envision that you would most likely do sort of production infrastructure, dev test infrastructure potentially is the top level we see it broken down at, but you can give them whatever names you like and carve them up however you like. Then within infrastructures, we have what are known as services. Services are a logical collection of what we call service roles. So let me start from service roles and move up. A service role is simply a virtual machine. It's the name that we give a virtual machine. So a service role is supplying a particular capability. Now that might be a fresh-based operating system, or it may be something that has something else installed. So again, going back to my previous example of SharePoint, you might have a 3-tier configuration. You'll have a web front end, some kind of middle service, Excel services or fast search or whatever it is, and then a database back end. All of those three things are defined within the context of the portal as service roles. And then collectively, They're known as a service. So you would potentially call that service SharePoint. Then from that service, then that is contained by an infrastructure. So it's very progressive and logical the way it breaks down. Business units requests infrastructures, and business units can have as many infrastructures as they need. Infrastructures contain services, and there can be as many services in an infrastructure as you need. And then services contain service roles, and there can be many of those within a service as you need. This is also the first level where we start talking about quotas. Now, you'll see when I go through the demo, when a business unit requests an infrastructure, they place an estimated quota on it in terms of amount of RAM and amount of storage which is going to be consumed by that infrastructure. And the reason why we're doing that up front is for the agility of the service. So under normal circumstances, if someone wanted to create a server, they need a virtual machine, they'll go to IT and say, hey, I need 2 virtual machines in test because I want to test a new application. The first thing the administrator does normally is check for capacity. Okay, they want 2 servers, they need X amount of RAM, they need X amount of storage. Do I have that capacity in my current system to service that request or not? We didn't really want that approval process to get in the way when a request is made. Remember I said I want to click on a button and I want to get a virtual machine spat out at the end of it. So if I have to then put a check for capacity step in there, that potentially slows down the agility of the service. So what we're doing with the concept of the infrastructure is we're pre-approving that capacity. So once the infrastructure has been approved, I know I have the capacity in place to support it, then business units are free to create as many virtual machines as they like within that infrastructure up to the limits of the infrastructure that was originally set. So they can carve up that infrastructure block however is appropriate. So once we've set our infrastructure limit on, or set the quota on the infrastructure, so in an example I usually give it, say they've requested 64 gig of RAM and a terabyte of storage, when you create your first service within that infrastructure, you place a quota on that as well. And that if, let's say I was going to create 2 services under that infrastructure, if I wanted to split them 50-50, I'd give them both 32 gig of RAM and 500 gig of storage respectively. The total that's assigned to each service collectively cannot be more than the total that was originally given to the infrastructure. Infrastructures contain services, so the total of those services can't exceed the total of the infrastructure. If people are hitting limits, they say, okay, I need to provision some more machines and I've hit my infrastructure limit, then the system has a change request process built in where they can go and request a change to that infrastructure to increase its capacity. Then obviously the administrator can approve or reject that request depending on whether or not the capacity is available. So you can see then the services obviously are contained within multiple infrastructures within that business unit, and then that process is repeated for however many additional business units are registered to the system. Okay, so let's have a talk about user roles. There are 4 in the portal by default, but the 2 that are the focus of how it works. First is a data center administrator. The data center administrator is the administrator of the portal and controls all of the resources that the portal touches and makes use of. So ultimately they're responsible for how much SAN storage they have, their IP load balancer configuration, their virtualization infrastructure and configuration. Obviously they care about security, they care about 24/7 monitoring and health of the system, and making sure that infrastructure is always available. The second user role is what's referred to as the BUIT, or the Business Unit Administrator. So you'll see these referred to as DCIT, so Data Center Administrator, and BUIT, Business Unit Administrator. So I'm using these terms because that's the terminology that's used throughout the portal and within the documentation. The Business Unit Administrator, obviously, is the owner of a particular business unit. So when a business unit registers to the system, the person who put that request in by default is granted the Business Unit Administrator role for that business unit. They then control that business unit and have admin rights to that business unit. Part of the goal of the SSP was to try and delegate a degree of authority down to the business unit to give them greater agility with what they do. So the business unit IT can control the security over that business unit. That's another departure from the first version of the SSP. where previously the administrator, or the SCVMM administrator to be exact, had full control and assigned authority to various resources. So if you wanted a particular person to have, or group to have access to a set of VMs but not to another, that's something that you'd again have to bother IT and they'd have to set that up for you. Within the context of the SSP, once you're a business unit administrator, you can then set the security within your environment however you like. And that's something that is largely transparent to the administrators. Or to the data center administrators, I should say. And the first level of granularity where that kicks in is at the service role. So as a business unit administrator, you could assign person A access to the VMs within one service, but then potentially not to another if you wanted to control it in that way. So let's have a look at the logical components and what you need to actually get this up and running. So we've got our two roles, primary roles there. We've got the DCIT and the BUIT. All administration and control of the SSP is all done through a web interface. So that's an IIS website. The product team were quite aggressive with the minimum support requirements for this thing. You've pretty much got to have the latest and greatest. So the web front end has to be installed on Windows Server 2008 R2. The web server then in turn talks to the engine server. The engine server is the guts of the portal, is where everything happens. It takes all the requests in, it queues everything, it processes everything. It also is responsible for communication to all other elements that you bring in that you want to interact with the service. Again, that has to be installed on Windows Server 2008 R2. SQL database is where everything's managed and controlled from the engine server perspective. That needs to be SQL Server 2008, and that can be installed on any operating system supported by SQL Server 2008. Those three roles can all function on the one server if required, or for scale they can be split out into separate boxes. Next, the engine server controls the virtualization infrastructure through System Center Virtual Machine Manager. That needs to be SCVMM 2008 R2. That communication is facilitated by the PowerShell applets provided to you within SCVMM. So you need to install the SCVMM admin console on the engine server because that's what provides you the PowerShell applets used by the server to facilitate its communication. And then the virtualization infrastructure then, or SCVMM then talks to your virtualization infrastructure, so potentially your cluster of Hyper-V hosts. It is worth noting that the SSP will support any hypervisor which is supported by System Center Virtual Machine Manager. So currently in SCVMM 2008 R2, we support Virtual Server, Hyper-V R1, Hyper-V R2, and also VMware ESX 3.5. Of course, all of that is then controlled from an ID management and authentication point of view by Active Directory. So let's just bleed all that away for a sec and just have a look at the engine server. Before I mentioned that the goal is end-to-end automation. So you may want to provision LUNs that are then connected to those virtual machines, or you may want to participate in an IP load balance scenario. And those are just examples. Within the portal, we give you a tremendous amount of flexibility. It's all controlled via scripting. So I don't have too much time to go into the extensibility engine in detail because I've got an hour session completely devoted to that because there's a lot of detail in it. In a nutshell, it allows you to string together any collection of scripts, which can be either VB, PowerShell, or command line. And they're tied together in something that looks quite similar to a task sequence. So if any of you are familiar with MDT or SCCM OSD, you'll know what a task sequence looks like. Very similar type of concept where you have a discrete set of actions being executed in order. There's a couple of really neat features that the scripting framework provides you. It gives you the ability to pass parameters seamlessly between one script and another. So if you've got an output from a VB script that you need to then make use of within a PowerShell script, the framework makes it very easy to do that. It also provides a list of runtime variables that are supplied by the portal for use in your scripts that are also very handy. When we first started on the early adopter program with this, and we started to talk about the integration with SANs and load balancers, one of the first questions that was asked to us by our early adopter customers was, okay, what models do you support? Give us a list of makes and models that you... It's not about makes and models. It's about having some kind of, the management utility of that equipment, having some kind of interface that we can hit with our scripting engine. So if your SAN management tool has a command line interface, we can use that. It wasn't really enough for us though just to say, okay, well if they've got a scripting interface then yeah, we can communicate with it, and if they don't, well, too bad. So the product team have been working very hard with a very large number of our partners such as HP, NetApp, F5, for them to start producing PowerShell applets for use for integration with their equipment. So you'll start to see some announcements very soon, and quite a number of them coming out about PowerShell applet support for equipment. And some of that, depending on the partner, will range. Some of it they'll just provide you the applets and say, there you go guys, knock yourselves out. Some of them are putting in a little bit of extra work. The last run of NetApp stuff that was released, not only did they release the applets, but they also wrote the extensibility scripts for you, so you can just plug them straight into the portal. So the engine server is the interface that then potentially communicates with a SAN device or a load balancer. Again, those are examples. The scripting engine is very flexible, so really, to a large extent, you're really only limited by your imagination and your talent in terms of scripting ability. You may also want to do more than just provision a bare bones virtual machine. You may want to deploy some kind of application or service post-OS deployment, so you could integrate with MDT or SCCM. Okay, so I've explained a little bit previously about the extensibility engine and what it's there to do. So it's there to provide that end-to-end automation through a scripting interface tied together in a task sequence style presentation. This is important to remember because when we start talking about delegation of creation of virtual machines to business units, admins start freaking out, especially around things like change control and those types of processes. So we would envision that you'd make use of the approval of the infrastructure process as to where your change control potentially would kick in. When a business unit requests a block of infrastructure, that would potentially go through your CAB or through your change control process to say this block of infrastructure is being reserved and virtual machines will just be provisioned within that environment. The way that you can then make the provisioning of those virtual machines truly dynamic without procedures getting in the way is the fact that through the extensibility engine, how those virtual machines are provisioned, so the process that is used to build them is completely built and controlled by IT. You're not delegating that to anyone. You're delegating them the ability to create them, but how they're created and what they look like when they get spat out the other end is entirely controlled by IT, and the control remains where it should. So I'm actually going to flick over to my demo machine now, and I'm going to say in advance so that people don't think I'm trying to trick anyone. These are pre-recorded, so they're not live demos. These are AVI files. Main reason is a lot of the demos that I'm about to show you are registration processes, filling in forms of information and that kind of stuff, and it's much easier for me to talk through it if I'm not having to worry about and concentrate on what I'm typing. So let me just go over here. My workstation's locked. Gotta love corporate security policies. Okay. This is what the interface portal looks like. As you can see, it's a website. I'm currently logged on as a data center administrator. The interface is security context trimmed, so the portal knows who you are and only gives you the options that are appropriate for your authority. So there are the tabs that you can see up the top there. I have access to all of those because I'm an administrator, and the portal knows that. If I was logging on as a standard user or as an anonymous user, you wouldn't see those tabs up the top, or you'd see a reduced subset. If I go into settings, this is the administrator's view of the portal, so this is how we configure it. The first option there is data center management, which is where we configure all of our back-end services. Next one down is templates. The core of the concept is to use SCVMM templates to provision your virtual machines. So that's where you configure them. And the third action there is virtual machine actions customizations, and that's the extensibility engine that I spoke of earlier. I don't go into it in this session because I simply don't have time, but I will point you to some related content where you can have a look at that scripting engine in much greater detail. And I hope you like PowerShell if you're planning to go and take a look at that. So I'll go up into data center management, and we'll take a look at how it looks from the administrator's view for how we configure our back-end services. So the first item up there is the SCVMM server that we're connecting with. That currently is a one-to-one relationship, so you can only point to one SCVMM server. If you have more than one in your environment, you then would have to potentially stand up multiple instances of the SSP. I can't imagine that anyone in New Zealand would be of such scale that they require more than one. The next area is the devices. Now this is where we configure our SAN and our load balancers. Again, you're not limited to those type of devices. You can really interface with anything that you can script, but SANs and load balancers were the things we felt would be the most common things that would be used in this style of provisioning engine. So we've added extra facility for those so that you can deal with those in a bit of a nicer way in terms of being known to the portal in a GUI sense. So to add a device, I simply give it a device name. In this case, I'm just saying F5 load balancer. The connection string is the connection string that the scripting interface will use to initiate connection to that device. So the syntax and how that's done is going to look very different potentially from manufacturer to manufacturer depending on what you're trying to connect with. So you can see there I'm just saying connect minus address and an IP as to something as to what a typical connection string might look like, and then you tell the system that it's a load balancer and it's added to the list. The next element is network. We can assign multiple networks that are then available to say when virtual machines are provisioned or when infrastructures are provisioned to say, yes, I want these VMs to connect to X, Y, and Z networks. We obviously give it a name. We can say connect to the corporate network, and that simply tells the portal that you want to join those virtual machines to a domain when they're provisioned. If you want them in a workgroup scenario, you may not want to join them in the domain, you just don't check that box. You can give them a specific VLAN tag, so the virtual NICs of the VMs will be automatically VLAN tagged if they're being connected to a network that needs to be on a particular VLAN. You can give them a dynamic address because everyone assigns addresses to servers in their data centers from DHCP, don't they? No? Anyone? Everyone still awake? What I'm doing up here now is I'm configuring a static address pool. So you can say on this network, this is the static address pool that I want you to assign a static IP address from. When the VM is provisioned, it'll simply grab the next address in the pool. Give it a list of domains that you can choose to potentially add the virtual machines to when they're created. So you can see, what is that, Contoso, Contoso dev.local.com.au, by the way. Contoso is an Australian company, for those who didn't know. Chargeback values, and I'll explain chargeback in detail when I go back to the slide deck, but this is the first time that we see it. Memory and storage cost, we're setting a value for those. And the next line is simply an environment. That's a freeform text field, so you can call it whatever you like. That's used when people select their virtual machines, what environment they're connecting to. That is available as a variable, as just about everything that you can set in the portal is available as a variable within the scripting extensibility engine. So when your provision scripts run, you may take one set of actions if the variable's production and one set of its development. I've just got into the template section where we add our templates from SCVMM. You can also see on the end that there's a chargeback value associated with the template. And in the slide, I'll explain how that works. So you don't automatically see every template that's in SCVMM. We have to go in and add them. So I'm just selecting my SCVMM server there and the library share. And then we have a list of templates that I could potentially add. So I'm just adding a 2003 and Windows 7 template to the list there. Assign them chargeback values. You can assign obviously any value you like. You may want to assign a different value to a 2003 operating system, say, to 2008 because there's more patching, more maintenance involved with 2003, so you might want to assign a higher cost to it as an example. And there we have our templates. Lastly, we'll have a look at user roles. So we've got our two that I covered in detail, the data center and the business unit administrator. The DC admin, you can obviously add any number of groups or individuals to that who can be administrators of the portal. You can have a look at your business unit administrators, who they are and what business units they're in charge of. People can be in charge of multiple business units, that's quite possible. They have full admin to their respective business units, and then can also undertake, you can see there, the list of virtual machine actions that are permitted, which is everything if you're a business unit administrator. You then have advanced operators, which have the same subset of VM actions, but don't have any access to the business unit itself, so they can't request infrastructures or make change control requests. And then you've got your standard user, which has a smaller subset of actions to virtual machines. So you can allow them to, say, create a virtual machine, but not to delete one, for example. You can also set up a custom role, give them any number of virtual machine actions that you like and save it. Once that custom role's been created, then that's available to any business unit administrator who wants that to be made available. So, for example, you might want to set up a custom role that only allows people to connect to VMs, for example, and do nothing else. Okay, so let's have a look at chargeback. I mentioned that before. You saw there are a couple of places there where I was assigning some chargeback values. Three things carry a numerical value in terms of chargeback. Memory, storage, and then virtual machine templates. I want to be very clear what we have and haven't done here. We haven't built an accounting system. This doesn't know about dollars. It doesn't know about exchange rates. It's not going to spit out an invoice at the end of the month. What it does is gives you a set of reporting data that you can feel completely free to ignore if you want to. You don't have to use the chargeback facility. Or you can make use of that data to have a look at your respective consumption rates across your business units and find out who your repeat offenders, your valued customers are amongst your business units. Or if you wish, you could potentially use that data as the basis of a financial transaction. Yeah? Okay. Okay, so let's have a look at it. Ooh. Yep. Okay. So, having a look at chargeback and how that breaks down. So, you saw before we placed there was a value in there for RAM and storage at the infrastructure level. All that does is set the default. So the first time a business unit creates an infrastructure and then creates a service within that infrastructure, when that goes to the admin for approval, and you'll see that process, they then set the real value for the service. So that value that you saw in the data center configuration is the default that gets taken automatically, but you can then override that at the service level. So at the service level is where the real charge is made. So we have a storage per gig per day for storage and a cost per gig per day for RAM. That gives us our reserved total. So what we may want to do, and you don't necessarily have to do it this way, but a lot of people may choose to, is when an infrastructure request comes in for 64 gig of RAM and a terabyte of storage, you may want to hard reserve that in the system so that nobody else can touch it, so that that capacity is available to that business unit when they demand it. If you're going to reserve that so that it isn't available for everyone else, it's taken out of your shared resource pool effectively. So you want to associate a charge for that infrastructure that's been reserved, and that's what the reserve total is all about. So the reserve total is simply the per gig per day cost RAM plus storage. The next thing that has a cost associated with it is a virtual machine, and a virtual machine has a cost and it has a set of hardware specs. So a virtual machine template may have 4 gig of RAM and 200 gig associated with it, for example. When that template then becomes a virtual machine and gets provisioned, it's actually taken out of the reserved pool. So for that template example, the 4 gig of RAM, the 200 is no longer reserved, it's now been allocated. So the reserve cost actually goes down because the amount of the reserve pool has just been reduced. You then add the cost per day for that virtual machine. And that virtual machine cost per day is the costing that you assign to the template. So the total charge per day is the reserved plus the cost of the virtual machines you have in play. So If that doesn't make much sense, I'll go through it again, but we'll put some numbers on it. So let's say that I'm assigning a value of 0.5 per day for storage and a value of 1 per day for RAM as an example. I've got an infrastructure with a terabyte of storage and 64 gig of RAM. So that's going to be 64 plus 500, which is going to give us a total of 564 per day for the reserved cost. Now again, this is not dollars, it's not an accounting system. How you equate that number back to something within your business is entirely up to you. So you can charge your business units in dollars or minties if you want to. It doesn't really matter. So again, I've got a virtual machine template, 200 gig of storage and 4 gig of RAM, and it's also been assigned a chargeback value of 110 units per day. When that becomes a virtual machine and I deploy it, the reserve numbers go down to 860 because that's what's left in the reserved pool. So my 564 just became 460 because my reserve cost has gone down because I've taken infrastructure out of the reserve pool. But we then add the cost per day for that virtual machine, which is 110. So that takes the total cost up to 570 from 564. So if you are going to make use of chargeback to gauge relative consumption rates across your business units, you do have to be mindful that where you set your template values. It's very, very easy to set them not high enough and to have an ever-reducing cost that'll end up, ultimately being zero. So I don't know, for some businesses that might be a chargeback model that works, but in most cases I would assume that you'd want the cost to go up as more virtual machines are provisioned. Okay, I'm actually going to wind up now and show you some demos of what it looks like from some other perspectives. So the first one will be a demo of what it looks like from the business unit requesting an infrastructure for the first time. So this is how it'll look for the user. Okay. So here I am, I'm logged on. At the moment I'm an anonymous user. I'm not known to the system, so I've got no tabs up the top. The only thing I can do is register a new business unit. Again, the interface is security context trimmed. So I simply supply a business unit name in my example. Actually, let me just pause it for a sec. I'll just tell you, for this example, let's look at a database section, for example. That database section wants to provision two types of service roles. They want to provision a bare operating system, which is going to be used for them to then put their database services on top for testing. But then they've also got another virtual machine which has a corporate standard installation of SQL Server that goes down over the top, which is what they provision by default in production. Now, prior to the portal, you'd have your database area, go to your infrastructure area and say, we need another couple of servers for testing or whatever, how much capacity have you got? And then you get thrown over the fence a few times, and then eventually your database management guys would get the servers they need. So this is the example that we're using in the following the demo through. So from here we'll go in and request a new business unit. This is the database guy going in. So give it a business unit name. So they're called database management. Well, actually they used to be called database management. Now then they just had a marketing guy start with them. So now they're called Cloud Information Services. You are awake. Provide a business unit code. 1234. I've got the same combination on my luggage. That's a compulsory field because it's marked with a red star. Contact email address, always usually a handy thing if you want to get in contact with somebody. Set a priority on the job, high, because jobs are always high priority. And a business justification, just need it. I think the person used to work for Nike. And that's the last of my jokes. And you can see there's the person's gotten confirmation that that request has now been entered into the system. So let's take a look at what that looks like from the administrator's point of view. So here we can see you go into the Requests tab. You can see that there is actually now an outstanding business unit registration request. I have all the details that were supplied, not that there was that much of it. There I can actually go in there and edit that if I wish. I'm an administrator. I've got eyes like a hawk and a mind like a steel trap. I know that the guy got his business unit code wrong, so I can go in and correct that. and then simply approve or reject the request. Obviously, if I approve or reject, I give a reason so that when the person then looks back into the portal, if the request was rejected, they can see why. And it's as simple as that. That's it. So then that business unit is now registered and known to the system. So I'll go into how that business unit then requests an infrastructure. So that person's now a known business unit administrator, so when they log into the portal, now they can see the extra tabs. They go into infrastructure, they have no infrastructures at this point, so they have to go and request one. So they'll go in here and request new infrastructure. Give it a name. In this case, they actually want an infrastructure for development, and then they want 2 services, one for testing and one for UAT. We can give it an estimated decommission date. The portal's not going to do anything nasty with that, so it's not going to start spooling down virtual machines when they hit that date. But again, as with pretty much everything in the portal, it is available as a variable to your extensibility engine. So you could write logic in your script if you wanted to say, am I past my estimated decommission date? And if I am, don't actually provision the virtual machines. They set their estimated quota for RAM and storage. So at this point, I want to say, while this demo is cranking through, what the point of that is. Now, we've got to remember what we're provisioning here. We're provisioning infrastructure as a service. This isn't software as a service. This isn't something that a standard non-IT literate user is going to consume. This is infrastructure as a service. So we're providing virtual machines and infrastructure to people that we assume they'll know what to do with it once they get it. And the business unit administrator is just that, an administrator. So they should actually have a fair degree of idea of the level of resources in terms of RAM and storage for what they're going to consume. So in there, they're actually setting their first service. So they've selected some their quotas. So they just split that 50-50. They're selecting which network they want it to be available on. They can request rapid provisioning if you've got that facility available. You might be using the NetApp cloning software or whatever it happens to be. Now that we've provisioned our service, we need to add a service role. You need to have an infrastructure needs to have at least one service and at least one service role in order to be created. So giving it an estimated number of virtual machines there, again, it's not going to do anything nasty, but it's, again, logic that you could potentially use in your extensibility scripts if you wish to. You can connect it to a load balancer if that's appropriate. So you can see now down the bottom they have their base OS service role, and they're going to add another service role because they wanted a base OS and then also an OS, which, a service role which then goes and installs SQL after the operating system has been deployed. So I've got my 2 services in play there. The next step is to simply select the templates that I want to be made available. That I want to consume. In this case, there's only one to select from, but if you had multiples, they could potentially pick multiple templates. Gives you a final summary, and then the request can be submitted. Again, they get confirmation that that's been done. So the final one is to have a look at what it looks like from the administrator to actually approve that service request. So again, I go into requests. I can see there are a few there now, but I've got an outstanding infrastructure request. You can see that there's a few elements there that have the yellow exclamation point on it. And that means that there are pieces of information that the administrator needs to supply before that section is regarded as complete. You may notice that up in the top there, the approve, it's greyed out. I can't click on it. I can't approve it because I haven't supplied all the information that the system needs. So we'll go into the service and have a look at what additional information. It's the same information that the business unit administrator supplied, except for the additional pieces of information that they couldn't give are then highlighted in yellow, and this is extra stuff the administrator needs to set up. So you can see here that you can select your SCVMM host group. So those familiar with host groups will know that they're different collections within SCVMM. You might want to say that this business unit's virtual machines only get configured within this particular host group within SCVMM. That can be quite handy in terms of separation of service and potentially different cost rates as well. So you might have multiple host groups, one of which is a collection of standalone hosts. that are a little bit cheaper to maintain, and they may be going back to some iSCSI or some cheaper storage that you may provision all your dev and test on. And then you may have another host group that has your high availability cluster with all of your very fast fibre channel SAN services, expensive disk, and you go and select that for production. Again, as an example. What I'm selecting here is it needs the SCVMM library that you're going to use to provision the templates from, which then it's going to know where to go and grab those. Obviously, you can have multiple library servers that potentially, may exist in different data centers, so you have to select the appropriate one. The next one, again, I'm selecting the same library server, but if I had multiples, I could choose. This is the library server where if a user or a business unit user wants to store a virtual machine back into the library, then that's the library that will be used for that. We can set our advanced operators and business unit operator or standard users at that time. And this is where we set our real chargeback values. So you can see there that we've got our default values that it grabbed from the back-end configuration that I showed you earlier. But this is where we set our real values at the service level. So this is where we can adjust the charge rates if that's appropriate per service. So for example, in this one here, again, I'm mentioning that SQL guys are always complaining that they don't have enough I/O and that it's always the I/O's fault and they need more spindles and faster disk and yada, yada, yada. So I'm just going to charge them a little bit extra for the complaint factor there. Not that you would really do that sort of thing at all. So I can just, I'll just move it forward a little bit. I can set those, obviously when I was rehearsing this, I planned that joke to go longer. So now I've got a green tick there, which means that the portal has all the information it needs, but I still can't approve it because there's other pieces of information at the service role level that I need to define. Again, the stuff that needs to be done is in yellow. I could assign that and give it specific information to which load balancer I want to connect it to with various connection parameters. The action script. Now this is the action XML segment, or think of it a bit like a task sequence, that gets used to provision that virtual machine. So a service role is associated with an action XML segment. And you can see there I just used the default. In this case for the SQL box, I have another different action XML segment that integrates with MDT to go and pull down and install SQL Server after the OS has been deployed. So I'll select that. So SQL Server 2008 as an action XML segment. And then save and close. So I've nearly got green ticks across the board, so I just need to confirm the template that they're using. This is the template that they've requested. I can provide them any template I wish. They may have requested 2008 server, but say in production we only support 2003 at this time, so then you can change that to 2003 so they get the appropriate template. But we're a progressive organisation and we support the latest and greatest, so 2008 R2 is just fine. Save and close, and now I have all the information that the portal needs to approve the request. I've got green ticks across the board. I can now approve that request. So once approved, then that business unit is then free, their infrastructure's there, they've got their pool of resources, they can now go and provision provision virtual machines to their heart's content. So that concludes me. There is some additional content. Unfortunately, because of we actually had a part 1, part 2, part 3 of this at TechEd Australia. This was part 1, the overview. Part 2 was diving deep into the extensibility engine to show you how that scripting and the end-to-end automation is achieved. And then part 3 was given by one of our storage partners, NetApp, who gave a talk on the storage implications of private cloud and how then that integrates with the SSP and things you may want to do at a storage level like private zoning and things like that. Unfortunately, because of the reduced time frame, TechEd New Zealand's 3 days, not 5, we couldn't fit all of the sessions in, so we only really had time for the overview session. But of course, all the TechEd content is available from the web post, so if you're interested in looking at more detail on the portal and the part 2 and part 3 sessions, they're available from the TechEd Australia website. System Center Virtual Machine Manager Self-Service Portal team blog was released last week, so that is now live, and that's a link for it there. So keep an eye on the blog for announcements and changes. Certainly as our partners start coming in, OEM partners start providing PowerShell applets and that extensibility starts to be being made available, that'll be announced up on the blog. I'm also going to do a blog series because we have integration with MDT and SCCM for management of both OS deployment and potential service or application deployment post-OS, and we'll have step-by-step guides that we'll be publishing on those blogs for that integration as well. I'm going to be waiting until release until that's done, because every time the guys release a new build, they break my stuff. So I've given up rewriting it for every iteration of the build they do. So we'll be releasing that post SSP release. And the last link up there is the link to the release candidate that you can go and download. It's obviously freely available. When the release, when the RTM comes out, that will also be a free download. So that will be a free extension to SCVMM. Okay, so thanks very much for your time. I'm not sure how much time I actually have left, but I'll take. There's no one standing here waiting to kick me off. So if anyone has any questions, I'll take those. No one? Silence? I'll take that to mean I expressed it so well that I answered absolutely any question that you may have had. Thanks. I'd like to say I'm here all week, but it's the last day, so.